This week on the show, we recap our vBSDcon 2019 experiences. We also cover Unix at 50, how that operating system came about. We have a tutorial or a bring-up of OpenBSD on a fanless Tuxedo InfinityBook for you. We also show you a bit about humungus, which is an HG server. And we also tell you how to configure a network dump in FreeBSD and more in this week's episode of BSD Now. BSD Now, episode 315, recapping vBSDcon 2019. Recorded for the 11th of September 2019. Hello, I'm your host, Benedikt Reuschling.
And I'm Alan Jude.
And we're both back from vBSDcon, which finished last week, so I'm just little bit of jet lag left, but most of it is done. And we had a blast at the conference, so we thought we reported a little bit about it.
Yeah, as with 2 years ago, when it was held in 2017, it was at the Hyatt Regency Reston. Basically, after 2015, they had done a poll to see if people preferred being a bit more in town, where you could easily walk to other things to get dinner and hang out or whatever, or to the slightly cheaper hotel that was basically in the middle of nowhere. And people voted for this option, and it's worked out very well. And so, yes, we had the main conference there. I arrived on Wednesday afternoon and met up with some people in the lobby who were around talking and so on. And then broke off with Michael Lucas, and we went and had piri-piri chicken for dinner.
Ah, that's a good start.
Yeah, it was nice to get to catch up with Lucas. We saw each other at BSDcon, but Lucas was awfully busy, and we didn't really get to talk much. So it was nice to have a quiet dinner with him in Reston.
Yeah, I flew out on the Tuesday and arrived fairly late in the evening, but that's just flight schedules. And then on the next day, I met up with Drew Levine and Warren Block, and we drove to Maryland and went to a maritime museum that was totally unrelated to the conference. And then... So we had a chance to talk there, what they're up to, what's the latest news at IX Systems from their perspective. And then they drove me back. They couldn't attend the conference, unfortunately, but that was a nice tourist day for me. And then I switched hotels on the next day because at 8 a.m. the breakfast was starting for vBSDcon, and I just barely finished checking into my hotel room. Fortunately enough, they could give me the room this early, and then I could join the developers for the first activities of the day.
This year was a bit different at vBSDcon because it was organized by Dan LeGill of BSDcon fame. So that didn't change that much, as same hotel and then same basic stuff. But the conference was quite good. Breakfast the first day was especially good. We had like hot egg and ham and cheese sandwiches and such.
Delicious.
Yes. And some nice fruit salad and so on. And so that first day, those of us who arrived early attended a FreeBSD hackathon where we worked on a number of different things. I worked with Steve Wills on getting a port of the application DocBook RX, which is a Ruby application that can convert DocBook XML into ASCII doc, which is basically a superset of Markdown. And working on that project to basically revamp the documentation system in FreeBSD. Steve got most of the way finished before the hurricane knocked out the power out of his house, whereas where the machine he was working on was from the conference. But he did manage to finish that up and send it to me, so I'm hoping this evening to have some time to get that port tested and committed.
Oh yeah, that would be great.
And I've got the first successful not hackish machine translation of the DocBooks markup into ASCII doc. And so now the working group is looking at what things are not good in the machine translation of the machine conversion. And then we will fix those up, improve the conversion tool some more, and then do another run. And then we'll just be down to a human pass of going through and cleaning up some of the markup and a bit of white space in a few places. I think for some reason in the introduction section, some of the titles of the sections are missing a space between the first and second word or something like that. Not a big deal.
And the converter can't deal with that yet.
I'm not sure if the problem was the converter or the original XML or what. But yes, clean up some stuff like that in a couple places like where tables exist, where we want to say, make this column more narrow or this column wider, and a couple of things that are only fixed up by humans but aren't a big deal. And then hopefully we'll get to a point where it's much easier for people to work on docs. So if you're interested in helping with just reviewing the markdown output and cleaning it up and getting stuff working, we'd very much appreciate the help. And soon it'll be much easier to update the docs. And then once that's done, we're hoping to expand that a bit and collect and curate a list of other bits of documentation, in particular kind of informal documentation like how-tos and guides and videos, and have a nice curated section of those so that if you're just a user and you just want to learn, how to set up a web server or something, there will be obviously the FreeBSD handbook has sections on how to install applications and how to do this and that, but sometimes it'll be helpful to have an informal guide that is like, okay, you need to set up, you want to install the package. If you want to know how to build packages, here's the link to that part of the handbook. And then, you install Apache or Nginx or whatever and do this. And then if you want to run it as a non-root user and you need to use port ACL to allow non-root to listen on a port like 80 and 443, then here's a link to that section of the handbook that covers that, and kind of just put it together so that you don't have to read the whole handbook to understand everything. Where it's just kind of a cross between a cross-reference and an informal guide, but make it easier to find stuff, and also to just try to separate the documentation into, to reorganize it based on target audience. This documentation is designed for people who are developers, and this one is for sysadmins, and this one's just for users. So that, you don't get the wires crossed there and get into documentation that's covering topics that isn't what you need. Or, if you're just an end user, you don't want the documentation on how to compile X and patch it. You just want to do package install X and make it work. And so kind of collect and collate all of that and make it nice. But more importantly, make it easier to have people contribute to those, and also to make it easier for those to be committed by being able to easily see what the output looks like and be like, yes, that's fine, hit approve, and it just happens, rather than requiring a bunch of extra steps.
So I worked a bit more on my little project that I started way back at the Aberdeen Hackathon, the BSD chapter, which has still not been committed because I had not too much time put into it over the summer. But now I have it in a shape where it's in its own chapter. So originally it was in the PF chapter, in the firewalls section. But then we thought, okay, this does not only work with PF, also IPFW can send BlackListD IPs that it should blacklist. So we thought it would be better to have its own chapter. And now I have it as an own chapter, and this is currently in the latest review. And I'm fairly sure that I'll be able to finish or to hash out the last bits after vBSDcon next week, where we can get that committed, and then people have it in the handbook. And then follow-up commits, of course, can provide more cleanups or links or some else that I missed.
Lots of people were there and worked on a variety of things. And then at the end of the day, we had the welcome dinner. So all the people who were just attending the conference had arrived sometime in the afternoon or whatever. And we all got to have dinner together and, get excited for the conference. As usual, the food was amazing. Thanks again to VeriSign for sponsoring and making sure we all got more than enough to eat.
Oh, yeah.
Eventually, we had our gelato run. Went out and had some gelato, and then we came back and hung out and stuff until it was time for bed.
That was a nice, plenty of activities in the morning, and then having a more relaxed session at night.
And then it was the first day of the conference. About 7 minutes later, it seemed like. Didn't get as much sleep as I would have liked. But the conference opened on an especially high note with a great keynote talk by Paul Vixie about the dangers of DNS over HTTPS. So it kind of talks about why they did it and why it's maybe not the right solution and what some of the problems are. And then he demoed a work in progress he has for being able to defeat it. The main point really of DNS over HTTPS is it's much harder for an ISP to say block port 443, where you're going to send these DNS over HTTPS queries, than it is for them to block, say, port 853, which is what DNS over TLS uses. But he showed how you can use passive DNS and some other techniques to actually detect when an endpoint is doing DNS over HTTPS and block it. So using IPFW and the divert socket, if you're basically talking to a host we haven't seen before, we divert it to his application, which then, having looked at reverse DNS and some other things, uses passive DNS to try all of the different host names that might point to that IP address to do a DNS over HTTPS request to them. The important thing here is you have to have the right host name in the server name indication field on the TLS packet. And so using passive DNS to iterate through those and try all the different options. And then if you get an answer, oh, this is definitely doing DOH. And so add it to the block list and so on. It was quite interesting to see applying passive DNS this way. And also fun to see IPFW and divert sockets being used in new and interesting ways.
Yeah, so he described also not just the technical stuff, but also some of the social intricacies of that.
I definitely agree with his point that while I understand what they're trying to do with DNS over HTTPS, it's not enough protection. If you're a dissident in a country, you're going to need a VPN and some other stuff as well, not just DNS over HTTPS, because while they can't see what your DNS query was, they see you made a query and then you connected to this IP address, which we know is Facebook or whatever. Pretty easy to guess what the DNS query you just did was. And so fear is that people will think DOH is going to protect them, and it's not. And it's going to result in them maybe not taking the extra steps they needed to take. And then, if you're already going to be using a VPN or something, then something like DNS over TLS makes a lot more sense.
Sure, yeah.
But really good talk. Highly recommend it. If you weren't at vBSDcon and now feel sad, it will be given again, actually, in Norway. So stay tuned next week next weekend for that talk.
Soon enough, yeah.
And then video from vBSDcon will probably come out shortly after Euro is over. So no matter what, you'll be able to catch it. And then next up, John Baldwin gave his talk, in-kernel TLS framing and encryption for FreeBSD, which basically started with a quick review of how web servers and so on have evolved in BSD since the 90s, starting with the original version where you had your typical loop where the web server gets a request, it reads some blocks off the disk, it writes those blocks into the socket, and it keeps doing that in a loop until it's sent the entire file. But in the 90s, BSD came up with this great concept called send file, where instead of the web server having to read chunks of the file via the kernel off the disk and then write the same data back to the kernel into a different buffer to send to the memory, the web server could just say, hey, kernel, I have this file open. Could you send this range of bytes from that file to this socket I also have open? So instead of copying the data off the disk into a kernel buffer, then copying from that kernel buffer to the user space buffer, then copy it to a second user space buffer, and then copy it again back to the kernel buffer and then use that to send it out the socket, the kernel could just read the pages into the page cache, share those to the MBUF, and send them out on the network, which worked great until TLS came along. Now we needed to encrypt the packets. So we couldn't use send file, and we had to go back to the early 90 ways of doing things, except for maybe with even another copy as we do the encryption. But in order to solve this, Netflix and an entire team of people worked on this, and then John Baldwin and others expanded out even more so that you do the typical thing where in your web server, like Nginx, you set up the encryption session, but then you take that session encryption key and do a set sock opt for that connection to say this is the key to use, and then you basically do a send file and it knows to encrypt all of the data with that key. And so you can go back to using send file. So that was a big improvement. But John's work expanded on that even more by, instead of doing the encryption in the kernel, it actually has the kernel offload the encryption to the network card. So if you have one of the Chelsea T6 based NICs that has support for this, you can actually have the kernel copy the data off the disk, DMA it directly to the network card, and the network card will actually do the encryption and send it out for you. So you get all the benefits of SendFile with the benefits of offloading the crypto to the NIC as well. And he also talked about dealing some of the complications with that. If you use, say, link aggregation to bind multiple network cards together, you need to make sure that it correctly handles the handoff between NICs so that the session key is actually set up on the NIC that you're actually sending the packets out of, so because you never want packets to end up going out unencrypted. Especially in the middle of an encryption session, they will just be considered invalid at that point.
Yeah, so that was John's talk, John Baldwin. And meanwhile, that session split a little bit because in the room adjacent to that, Brian Callahan was giving a separate session, which is longer than the 1 hour sessions, about learning to OpenBSD or to BSD through its porting system, an attendee-driven educational session where people had the chance to learn about how to create ports for the BSDs. And that was basically couple hours, so people could really sit down and work on some things hands-on, while in the other room the talks were continuing.
Yeah, I think about 20% of the attendees went to that talk instead.
Yeah, so that was a bit more hands-on, and I guess that was a test whether that would be well received at the conference, and I'm fairly sure it was.
Yeah, I heard from a number of attendees that they would like to see tutorials next time, because a lot of them can get the time during the week and get the conference paid for if there's training involved. And so we're going to definitely do a push for that for next time.
Yeah, but back to the talks. David Fullert gave a talk about transitioning from FreeNAS to FreeBSD, and that was his first talk at a BSD conference. So he put all his courage together and gave the talk, and it was well received and plenty well prepared. And so he described how he built his own home NAS system or setup by trying to replicate FreeNAS from where he was originally coming from. So he used basically FreeBSD and recreated as best as he could or as much as he needed to the functionality of FreeNAS on FreeBSD. And he talked a bit about how that worked and what kind of stumbling stones he encountered. And the idea was that he transitioned basically from an appliance to using vanilla FreeBSD, but using the same tools from the ports collection, he could basically set up the same kind of system.
Yeah, basically, as he used FreeNAS more and more, he wanted to know a bit more of how it worked and do slightly more advanced things. And so he transitioned to vanilla FreeBSD, where it's easier to make changes. But it was a good perspective on what things look like as a new user. How the FreeBSD handbook is very good and useful, but isn't always the best way to find the quicker answers sometimes, and things like that, and so on. And also talked a bit about this type of thing as a recruiting avenue, as was talked about back in 2017 at vBSDcon. the way that most of the current FreeBSD developers got into FreeBSD might not actually exist that way anymore. People don't do IRC nearly as much as they used to, and that's how I got into FreeBSD, and so on. As we did our interviews in the early days of BSD Now, lots of people got started at dial-up ISPs and so on, and that's just not how the world works anymore.
It changed a bit, yeah.
Oftentimes, we have to start looking at the new ways that people get into the project, and a big chunk of that could be through appliances like FreeNAS and pfSense. And how do we foster that, and how do we make more of that and make it easier, and so on.
Yeah, so that was good. And David got his BSD batteries fairly well charged. And later on, he talked to us about some idea that he took over that FreeNAS has, and that should be in FreeBSD. And so he started doing some initial work on a prototype. And yeah, who knows where this is going to.
Yes, he asked for a new feature, which was having FreeBSD update create a boot environment before it installs an update. And then he got suckered into actually writing the code for it. And I helped him interface with Kyle Evans to get some of the prerequisites. So the BECTL program that you use to create boot environments now has an extra subcommand for just confirming if the system is already configured to use boot environments or if it's not available, so that FreeBSD update can tell if you're already using boot environments or not, and not ask you if you would like to create a boot environment when you can't. But yes, it was coming along quite nicely, and we will be sure to find more things for Dave to do.
Yeah, it always ends this way.
Yep. Then Sean Webb gave his talk, a summary of what's happening in hardened BSD and what some of what all the different mitigations that exist are. Then Benedict gave his talk about replacing Oracle databases that had gone out of support with FreeBSD, ZFS, and Postgres. Basically how they liberated the university from the clutches of Oracle without losing functionality.
That was well received. I even got someone from another German university contacting me, wanted the slides, and then he talked about his own setup a bit, that he's using FreeBSD, so I'm definitely keeping in touch.
And then to close off the day, we had an entertaining and educational talk by Michael W. Lucas, looking at the 20 years of FreeBSD jails. And after that, we had a little bit of break time, hung out and talked with a group of people about a number of different things, ZFS and system stuff and hardware, and just getting to hang out and talk with people that like to talk about the same geeky things I do. And then people broke up and went out for a variety of different dinners. I actually met up with some friends from the area who aren't into BSD, actually, and we went out for dinner as well. So I got to meet some people I've known online for at least a dozen years or so, and actually go to dinner with them. So that was nice too.
And I have to say, there are a lot of BSD Now enthusiasts at the conference. We got talked to a number, or people talked to a number of us, or to us, because JT was also there later on, and we were well received.
Yeah, he arrived about halfway through Friday because he had to try. He lives in the area, but like 3 hours away.
Yeah. Driving is taking time away. But yeah, people like the show. They gave us feedback, and that was nice to see.
Various other times in the hallway, talked about a number of different things, including at one point on Saturday, I think, between the end of the last talk and before dinner, we ended up having a talk about which Star Trek is better.
Oh, yes. Yeah. That got a nice little circle of people talking.
Yes. And, I felt that Colin and I were correct that it's DS9.
Shots were fired.
But speaking of Colin, Colin was the keynote speaker for the beginning of the second day. I wish I had gotten a little more sleep. Yeah, I had to concentrate to keep my eyes from crossing, not because it was overly complicated, just because I was so tired. But yes, he gave a very good talk looking at the 23 years of software side channel attacks and talking about how some of those work and, explaining some of the terminology and so on, and really put a lot of the Spectre Meltdown type stuff into context for people in a very understandable way. That was quite good. And again, that one will be at vBSDcon as well. So if you missed it, you have a second chance. Then I gave my talk, explained like I'm 5 how ZFS caching works, talked about the ZFS adapter replacement cache and how it works and how you can tune it. If you missed that one, you're out of luck. Well, you can go to FOSDEM's website and find the video from the version I gave in January. I will be speaking at vBSDcon, but it will not be on that topic. It will be on just the OpenZFS transition and so on, rather than about that one.
The ARC, yeah.
And then following that, we had some more ZFS goodness. Michael Dexter talked about his ZFS performance results across 6 different operating systems. So now that OpenZFS has been ported so many places, the question is, how fast is it on each of these platforms? So he compared FreeBSD and FreeBSD with the new OpenZFS port, NetBSD, Illumos, Linux, Mac OS X, and Windows, and saw what performance differences there might have been under different workloads. Quite a bit more to be done there to get more meaningful numbers and investigate, in some cases, why one platform is different than others. But it's an interesting start.
And then another newbie to speaking at a BSD conference, Connor Bay, was there. And he talked about FreeBSD at work, building a network and storage infrastructure with pfSense and FreeNAS. So I met him at MeetBSD last year. And yeah, he's a very bright individual and very excited and enthusiastic about the BSDs. The company soon came to a close, but we had 2 more talks from OpenBSD folks. One from Kurt Wojciechuk, hope that's correct, with his talk about care and feeding of OpenBSD porters. So he talked about all kinds of things people, when they write software that later will be ported to OpenBSD, usually are not aware of, or some intricacies of the actual porting process. That was interesting. And the last speaker was Aaron Poffenberger with the Road Warrior Disaster Recovery, secure, synchronized, and backed up. So he talked about all things that you want to do and need to do to back up your machine in case it gets lost, stolen, or just get damaged. And that was including some interesting ways how he backs up his machine, how he recovers, and some learnings from past experiences.
Because it was based on OpenBSD, it was interesting to see basically on the same disk having a second partition encrypted with a different key, and then using dump and restore to back it up, using that to approximate a ZFS snapshot of the system, and then separately having backup on an external media and a replicated backup to a remote location. Various stages of backup, because, if the only backup of your laptop is in the cloud and all you have is hotel Wi-Fi, it might take you the entire length of the conference to re-download your system. Whereas if you have a copy of the system on a USB stick or external NVMe device, then you can probably restore it very quickly. Or, if it's a matter of, I accidentally munged this one file, having that dump of the file system available to restore from can be handy.
Sure, yeah.
And so that was the end of the second day of the conference, or the last day of the conference. And we had another dinner. It was also very nice. They had sliders and pizza, or flatbread, fancy pizza, and buffalo chicken spring rolls, which were really good.
Oh, yeah.
And then cookies and all that stuff. Oh, actually, right before the end, there was also the last-minute charity auction.
Oh, yes, of course.
We auctioned off a number of things, including apparently for the OpenBSD hackathon at BSDcon, Bob Beck accidentally bought a 10100 megabit switch instead of a gigabit switch.
Oh.
So we auctioned that off. Then we auctioned off the signed note where Bob Beck admitted that he had made this mistake and that this switch wasn't just some random switch not worth very much money and not very useful, but was in fact an artifact proving that Bob didn't make the mistake. And so the person who bought the switch then had to bid against other people in order to try to get the letter of authenticity that made the switch worth having in the first place.
And not to forget the bag where the switch was transported in.
Yes. At the end, we also sold the conference bag that it came in. There was also a copy of the ZFS Dale's book with the hand-drawn by Lucas in crayon cover art. That would be, if Lucas was in jail and couldn't afford a real artist to do the cover art, this is what you would get. That sold well.
The first edition of Pseudo Mastery and the last one, because Pseudo Mastery second edition is out now.
Yes, it was the very last copy of the first edition of Pseudo Mastery.
Yeah, so all these items found a new owner. And how much money did we raise on this auction?
I think Dan said it was about $500 something for Shriners Hospital. He has a tweet and Facebook post about it, and there will be a picture of the receipt for the donation going up shortly.
Yeah, so that was a more humorous note, and then we had dinner, as we mentioned, and so that conference closed out. So yeah, we want to thank all the vBSDcon organizers, and especially Dan, for running such a great conference. It was well received. Everyone was only having good, positive comments about it. The video crew was awesome, and we just could focus on talking to each other without having to, how do we organize dinners, or how do we do this or that? It was all very, very smooth. We're also grateful to VeriSign, who actually are the main sponsor of this, so that's why the name vBSDcon is called this way. And the FreeBSD Foundation sponsored the toady bags that had the foundation logo on it, and those were nice bags, so if you weren't there, you're missing out. And of course, thanks to all the speakers and attendees who came out and provided another nice way of showing that the BSDs are not dying. All right, but that wasn't everything that we wanted to tell you in this episode. We also have Humungus, an HG server from Teddy Unangst. At least it's hosted on his website. And what's this? I've heard about HG briefly. It's basically a version control system, if I'm not mistaken.
Yeah, so HG is Mercurial, which is a version control system, similar, basically like Git, and I think developed slightly before Git, but different.
So this is a server he set up, or that he wrote?
Yes, I think this is a replacement server for Mercurial. It allows you to view changes, files, change sets, supports syntax highlighting. It's read-only. It can serve multiple repositories, allows cloning via obvious URLs, so it supports go-get if you're writing applications in Go. It can serve files for downloads, has online documentation via Mandoc, and has a terminal-based admin interface.
Oh, okay. And it lists a couple of requirements. Of course, Mercurial in the first place, as well as a couple of other ports.
The first two there look like they're from Garrett Demore, who's from the Illumos project.
Yeah, could very well be.
But then he shows making 3 different repos and all that interesting stuff.
Okay, so people should try this out.
Yeah, if you like Mercurial, this definitely looks interesting.
So yeah, maybe we will see a talk about this at a future conference, maybe when it's ready for prime time, or ready to be included as a talk. So yeah, people should check this out and provide feedback. All right, time to get into the news roundup this week. We have found a tutorial or a setup for OpenBSD on a fanless Tuxedo InfinityBook 14-inch. And that's the version 2 of the hardware. And this is over at hazardous.org and talks about how to set this up. So the too long didn't read at the beginning is that the InfinityBook 14-inch version 2 is a fanless 13-inch notebook. It's an excellent choice for running OpenBSD, but order it with the supported wireless card. And that's more in the actual notes in the main article. So they set up the dual boot configuration so that it can switch between Linux and OpenBSD. And to mainly spot differences in the drivers, Tuxedo allows a variety of configurations through their web shop. So you can pick and choose what you like best in your hardware configuration. And the dual boot setup with grub2 and EFI boot will be covered in a separate blog post. That's maybe in a future episode. Otherwise, check out the headers blog. In their tests, they did with OpenBSD current, which is, as of this writing, flagged as 6.6 beta, so fairly close to being the final release. So they provide also the full D message, so you can see what this machine has under its hood, or at least what kind of drivers are they detected. The CPU is a Core i5-8200Y. This is the 8th generation of the i5, called the Amber Lake Y. And you can see what kind of things are supported. That's fairly nice, fairly standard. And it's a dual-core CPU with 4 threads, so it can do a bit of damage compiling things, among other stuff. And now for the wireless. Since the device does not come with an Ethernet port, wireless communication is even more important, so they cover that first. Initially, they were announcing that this model came with an Intel Dual AC9260 wireless card, but this card is currently not supported by the IWM driver in none of the BSDs, that is. And so the Tuxedo added the Intel Dual AC8265 to the device selection, and the 8265 is supported by IWM. So the card features Bluetooth as well, but since OpenBSD has no Bluetooth support, the Bluetooth part just attaches as a generic USB device.
You might be able to disable Bluetooth entirely in the BIOS and save a bit of battery power by not powering it up.
Oh yeah, that can work, yeah. And so the video device comes with an Intel UHD Graphics 615 and gets, of course, detected with the resolution of 1920 by 1080. And they write that they are very happy that the display is not one of those high glossy displays, but instead comes with a matte resolution of the mentioned 1920 by 1080 IPS. So installation, they write, went flawlessly. The needed Intel firmware is being installed after installation automatically via FW update. And out of the box, the graphics works, and once installed, the machine presents the login. Fairly straightforward. Good to see that this works. External videos working just fine. The machine offers a micro HDMI port as well as a USB 3.1 Type-C with display port. They only tested a display port connection to the USB-C, but that worked perfect. And the display port delivers 4K at 60 Hz.
Nice.
The laptop can also be charged through that USB Type-C as well. That's very good to have.
Yes, I very much like that for my Lenovo, because I can get away with carrying one charger instead of 2.
Yep.
And also, my phone can charge off that too, and makes it super handy.
There are buttons for adjusting the brightness. They are not working yet. Instead, one has to use the WS control, or WS-cons control, to be more precise, to adjust brightness, but that's fairly straightforward as well. They talk also about the webcam, which is fully supported and works nicely. Audio has the Azalea chipset, which is being used for audio processing. And the volume can be adjusted through the function keys and mixer CTL.
But yeah, looking at the table at the bottom here, the audio works with the Azalea driver. Battery status works with the ACPI BAT driver. Bluetooth is not supported by OpenBSD. Suspend and resume and hibernate both work with the APM driver. The keyboard backlight works. Function key plus space toggles through 3 different levels of backlight. The micro SD card reader currently doesn't work. Theoretically, it should work with the SDMMC driver, but there seems to be some problems initializing it. Likely needs minor update to the driver, so there's hope for that one. The touchpad works. The USB works, including the USB-C port. Has Intel DRM video, so that works. The webcam works with uVideo and can be disabled in the BIOS if you don't want a webcam. And like we mentioned, if you get the 8265 model of wireless, then it works with the IWM card.
So yeah, seems like a decent machine.
If you're interested in the SD card bug, they have all the output in the post here, including running with the SDMMC debug flag.
Okay, not too much hassle there.
Mm-hmm. So next up, we have a nice big story from Ars Technica about Unix turning 50 years old and how the OS that powers most smartphones, started from a failure. So it says, maybe its pervasiveness has long obscured its origin. But Unix, the operating system that in one derivative or another powers nearly every smartphone sold worldwide, was born 50 years ago from a failure of an ambitious project that involved titans of industry like Bell Labs, General Electric, and MIT University. Largely the brainchild of a few programmers at Bell Labs, the untold story of Unix begins with a meeting on the top floor of the otherwise unremarkable annex to the sprawling Bell Labs complex at Murray Hill, New Jersey. It was a bright, cold Monday, the last day of March 1969, and the Computer Sciences Department was hosting a distinguished guest, Bill Baker, the Bell Labs vice president, and Ed David, the director of research. Baker was about to pull the plug on Multics, the condensed form of the Multiplex Information and Computing Service, a software project that the Computer Sciences Department had been working on for the last 4 years. Multics was 2 years overdue, way over budget, and functionally only in the loosest possible understanding of the term. Trying to put the best spin possible on what was clearly an abject failure, Baker gave a speech in which he claimed that Bell Labs had accomplished everything that it was trying to accomplish in Multics, and that they no longer needed to work on the project. As Burke Taug, a staffer present at the meeting, later told Princeton University, like Vietnam, he declared victory and got out of Multics. Within the department, this announcement was hardly unexpected. The programmers were acutely aware of the various issues with both the scope of the project and the computer they were being asked to build it for. By then, I'm sure the hardware that the software was going to run on was already out of date. But they said still, it was something to work on. And as long as Bell Labs was working on Multics, they would also have a $7 million mainframe computer to play around with in their spare time. Dennis Ritchie, one of the programmers working on Multics, later said they all felt some stake in the success of the project, even though they knew the odds of success were exceedingly remote. But the cancellation of Multics meant the end of the only project that the programmers in the Computer Sciences Department had to work on. And it also meant the loss of the only computer in the Computer Science Department. The GE 645 mainframe was taken apart and hauled off, and the Computer Science Department resources were reduced to little more than office supplies and a few terminals. But, with some perseverance, they ended up building stuff. And if you go read the whole story, it's only about 3 pages. It's really good. But I wanted to grab a few of my favorite excerpts from it. So one of them here is, in the early 60s, Bill Ninke, a researcher in the acoustics department, had demonstrated a rudimentary graphical user interface with a DEC PDP-7 mini computer. So the acoustics department was involved in speech recognition and speech synthesis and so on, because after all, Bell Labs was for the phone company, right? Turns out voice was a big thing for them. Anyway, acoustics still had that PDP-7, but they weren't using it and had stuck it somewhere out of the way on the 6th floor because, they had more powerful computers or just didn't need that PDP-7. And so Thompson, an indefatigable explorer of the lab's nooks and crannies, finally found that PDP-7, shoved in a corner shortly after Davis and Baker had canceled Multics and taken away the mainframe. So now the computer science department had found a computer to use. That concept of, a computer science department only having one computer and it getting taken away seems a little ridiculous today. Considering that many of us carry at least 2 computers with us at any time.
Yeah.
With the rest of the team's help, Thompson bundled up the various pieces of the PDP-7, which you have to remember was the larger than a refrigerator, not even including the terminal that you sat at. But they moved it into a closet assigned to the acoustics department and managed to get it back up and running. One way or another, they convinced the acoustics department to provide space for the computer and also to pay for the not infrequent repairs out of the acoustics department's budget.
Okay.
So now McElroy's team of programmers suddenly had a computer again, kind of. So in the summer of 1969, Thomas, Ritchie, and Kennedy hashed out the basics for a file manager that would run on this PDP-7. That was no simple task. Back then, most computers were batch computing, meaning you run program, and when it's done, maybe you run another program. So you run programs one after another. Rarely required the computer to actually be able to permanently store any information. And many mainframes did not have any type of permanent storage device. No tape, no hard drive, etc. So, you would feed data into it, it would process it, and generate the output, often on paper. And there was no storage at all. But the time-sharing environment that these programmers had fallen in love with required attached storage. And with the multiple users connected to the same computer at the same time, the file manager had to be written well enough to keep one user's files from being written over by another user's files. And when a file was read, the output from that file had to be sent to the right user, the one who had opened it. Sounds really rudimentary, but nobody had invented this yet. And so making sure that the right user gets the content from the right file, and that when you save the file, you don't accidentally overwrite anybody else's stuff. Nowadays, we would most likely call most of that a file system, but they didn't have that term yet. So they just had a file manager. And I don't think they didn't have the concept of sorting things into directories yet either.
Yeah, that came later, much later.
You would have so little storage that you would just have your couple of files in your file manager. There was no file system or directories or any of that. It turned out to be the challenge that McElroy's team was willing to accept. They had seen the future of computing when they worked on Multics, and they wanted to explore it. They knew that Multics was a dead end, but they had discovered the possibilities opened up by having a shared development with shared access and real-time computing. 20 years later, Ritchie characterized it for the Princeton research paper as, what we wanted to preserve was not just a good environment in which to do programming, but a system around which a fellowship could form.
I think they succeeded with that.
But they kind of, without even realizing it, understood the fact that this was going to end up as these projects where a bunch of people would work together to do something.
With their system or the follow-up.
And that, they didn't want just a better environment for them to write their code in. They wanted to basically build a community around it. So another excerpt here. Eventually, when they had the file manager system more or less fleshed out conceptually, it came time to actually write the code. The trio, all of whom had terrible handwriting, decided to use the lab's dictation service. So one of them called up a telephone extension at the lab and dictated the entire code base into a tape recorder. And thus, some unidentified clerical worker or workers soon had the unenviable task of trying to convert that tape into code. Of course, this was done imperfectly. Among various errors, inode, spelled I-N-O-D-E, came out as inode, E-Y-E space N-O-D-E. But the output was still viewed as a decided improvement over their handwriting and associated scribbles. Even nowadays, dictating code seems rather difficult.
Oh, yeah. And long.
So another excerpt. In August of 1969, Thompson's wife and son went on a 3-week vacation to see her family out in Berkeley. And Thompson decided to spend that time writing an assembler, a file editor, and a kernel to manage the PDP-7 processor. This would turn the group's file manager into a fully fledged operating system. He generously allocated himself 1 week for each of those 3 tasks. So 1 week to write an assembler, 1 week to write a file editor, and 1 week to write a kernel.
But it's interesting to see that the file manager came before the actual kernel.
Well, yes, at least the idea of it, yeah. Thompson finished his task more or less on schedule. And by September, the computer science department at Bell Labs had an operating system running on their PDP-7, and it wasn't Multics. And then later, by the summer of 1970, the team had attached a tape drive to their PDB-7, and their blossoming OS also had a growing selection of tools for programmers, several of which still persist today. But despite the successes, Thompson, Kennedy, and Ritchie were still being rebuffed by labs management in their effort to get a new computer. So they were just stuck with this old PDP-7 they found in a corner where nobody was using it. So it wasn't until late in 1971 that the computer science department got a truly modern computer. The Unix team had developed several tools designed to automatically format text files for printing over the past year or so. They had done so to simplify the process of documentation for their pet project, but their tools had escaped and were being used by several researchers elsewhere on the top floor of the building.
Whoops.
At the same time, the legal department was preparing to spend an absolute fortune on a mainframe computer and program called Astrotext. When the Unix team caught wind of this, they realized that they could, with a little effort, upgrade the tools they had built and written for their own use into something that the legal department could use to prepare patent applications. So, with this, the computer science department pitched to the lab's management the purchase of a PDP-11 for document production purposes. Yes, that's what it's for. We're going to produce documents. We won't write it OS or something. And Max Matthews offered to pay for the machine out of the acoustic department's budget. And then finally, management gave in and purchased a computer for the Unix team to play with. Eventually, word leaked out about this operating system, and businesses and institutions who had PDP-11s began contacting Bell Labs about their new operating system. So the lab made the code available for free, requesting only the cost of postage and whatever media that you wanted it copied to. And the rest is quite literally tech history. So you can read on a little bit about how eventually the code made it to Berkeley, and then it became FreeBSD and NetBSD and OpenBSD and so on.
So the history parts in that is always interesting because there's these stories in there that actually make you, appreciate how long this system has been alive and is being kept alive still today and polished and adapted to modern systems coming up way after the PDP-11s. Very cool. To a bit more modern things now, we have an article by Mariusz Zaborski in his blog, How to Configure a Network Dump in FreeBSD. So first you want to know, what is a network dump? So he describes that a network dump might be very useful for collecting kernel crash dumps from embedded machines and machines with a larger amount of RAM than available swap partition size. So you have much more to dump than the swap space can take. Besides those, net dumps can also be used to compress the core dump. So if you have a core dump from a program or from the kernel itself, then these can also be used to preserve that. However, often this may still not be enough swap to keep the whole core dump. In such situations, using the network dump is a convenient and reliable way for collecting the kernel dump. So he has a bit of history there for the implementation in FreeBSD. The first implementation of the network dump was implemented around 2000 for the FreeBSD 4.x as a kernel module. The code was implemented in 2010 with the intention of being part of FreeBSD 9.0. However, the code never landed in FreeBSD. Finally, in 2018, with the commit that's linked from the article by Mark Johnston, the netdump client code landed in FreeBSD. Subsequently, many other commitments were then implemented to add support for the different drivers. And the first official release of FreeBSD which supported netdump is FreeBSD 12.0. So, but how do you configure these network dumps? So for that, you need two machines. One machine is to collect the core dump, and let's call it the server. And the other one, the second one, is used to send the core dump to the client. Oh no, to send. So one is the sender, one's the receiver. The server receives and the client is sending. So to configure the client, we have to use the dump on command, and that has a couple of switches. And it basically allows us to configure the IP address of the server using the S option, the IP which should be used to send the packages with the C options. And then it is necessary to provide the gateway so that they know how to reach that machine. And from some time ago, we can also encrypt our core dumps, which may well be useful if you don't want to send unencrypted kernel memory in the network, because in that kernel memory there might be passwords or other secrets that you want to keep away from prying eyes. So that's why we encrypt these kernel dumps. And the basic configuration for the server, client and the interface, is basically dump on -s, your IP address of the server, then -c for the client's IP address, and then the network card. In this case, it's VTnet 0, but you can basically exchange that with any other network interface you have. It's very straightforward, and that's all that we need to do on the client side. On the server, we have to install the additional port netdumpd. So that's a package install away, just netdumpd, the package, and then you have that installed. After that, you can now run the netdumpd, so the daemon needs to run, and it needs no additional privileges, turns out. We can now use our user or create special user responsible for collecting those dumps. But he writes that please remember to keep the core dumps in a safe place so that not all users have access to it. Because again, people can look at those dumps and, can infer some memory information that might lead to secrets being exploited. But to run the netdumpd server is basically running netdumpd -D-lowercase d, and then your path where the network dumps should be stored. That seems fairly straightforward. And he describes also how to force a panic and how to send those dumps over. So look at the rest of this. It's a fairly well written article, and you should be able to dump your stuff to the network in no time. All right, it's time for the Beastie Bits this week. Our first entry here is what we mentioned earlier in the show, that Sudo Mastery 2nd edition is out now.
Yes, and I think he sold out of copies at vBSDcon.
He had some prints there for people, so they could get upgraded to the latest version. Because there were some changes in...
A lot has changed.
So that warranted a new book altogether.
And you can get the paperback, ebook, or hardcover anywhere mediocre or better books are sold. So if you want for your buy it on Amazon or for a Kindle, or if you want it to all the other ebook readers and so on, or you can get it directly from Michael's website without DRM.
And congratulations, Michael, on your latest book. And he has already made plans for future books in the tech area. So then we have empirical notes on the interaction between continuous kernel fuzzing and development.
So it says, fuzzing has been studied and applied ever since the 1990s. Automated and continuous fuzzing has recently been applied also to open source projects, including Linux and the BSD kernels. This paper concentrates on the practical aspects of continuous kernel fuzzing in 4 open source kernels. Accordingly to the results, there are over 800 unresolved crashes reported for the 4 kernels by the syscallers/sysbot framework. Many of these have been reported relatively long time ago. Interestingly, fuzzing introduced bugs have been resolved in the BSD kernels more rapidly. Fuzzing induced, not introduced. Furthermore, assertions and debug checks used after freeze and general protection faults account for the majority of the bug types in the Linux kernel. But 23% of the fixed bugs in the Linux kernel have either went through code review or additional testing. And then finally, only code churn provides a weak statistics signal for explaining the associated bug fixing times for the Linux kernel. So they look at Linux and a couple of BSDs and see how fuzzing has changed how development happens.
So this is a very academic paper, but there are slides and pictures in there where you can see the number of open bugs for each of those systems compared to Linux, as well as the closed bugs. So that's not just opening a bug, but also how people take care of them. And they have some more information about how they start the bug types, or they group them together, and how they reviewed and tested commits were distributed over the systems, as well as the actual types of bugs, like warnings or use after free or out of bounds checks. It's very well worth reading, and yet another great example how fuzzers can help find bugs and, if people take care of them, fix them, make the operating system more robust.
So next we have on GitHub here, Soso a simple Unix-like operating system. It's a simple Unix-like operating system written in NASM, which is a dialect of x86 assembly, and mostly in C. It supports multi-boot, so it can be started by grub, and it can also build using NASM and Clang. You can use GCC instead of Clang if you want. Tested build environments are Linux, FreeBSD, and Windows 10 using the Windows subsystem for Linux. So it's a 32-bit x86 operating system with multitasking, memory paging with 4 megabyte pages. Kernel space runs in ring 0 and user space in ring 3. A virtual file system, FAT32 file system, system calls, libc, user space programs as ELF files, mmap support, frame buffered graphics, and shared memory.
Ooh, that's quite something.
And of course, it can run Doom.
That's the test for each operating system. If it can't run Doom, it's not interesting.
Exactly.
Oh, yeah, great. They also have build instructions if you want to try it out and see for yourself. Not just for playing Doom, but also what the system can do.
Yeah, I guess interesting choice to go with FATFS, but I'm guessing the main reason is it's a very simple file system and saves writing a bunch of code or porting something more complicated.
Oh, yeah. So it runs in QEMU, but other than that, it's a nice effort.
Next, we have a talk from the keynote at a Linux conference about MDS, Fallout, Zombieland, and Linux, and a bunch of other of those side channel attacks and so on. And one of the Linux maintainers, Greg Pro Hartman, or Greg KH, we have a timestamp link directly to the point in the video where the Linux developer says OpenBSD was right.
So you can jump right into the action and see why that is.
So basically, when we saw Spectre and Meltdown, and some of the other stuff, OpenBSD, not unreasonably, guessed that there'd be more problems of this type found as people dug into it. So they disabled symmetric multi-threading on all their Intel chips back in June of 2018, and repeated the plea for everybody else to disable it in August of 2018. And it turns out that prevents most of the MDS issues automatically, and how they chose security over performance. And maybe there's lessons there that Linux could learn.
Okay.
Then we have another interesting one. I guess this week is the week of the version control systems. The new tool out of the OpenBSD arena is Game of Trees.
Commit is coming.
So Game of Trees has a number of properties that make it unique among version control systems. First, the code base is easy for OpenBSD developers to read, audit, and develop because it employs coding and design conventions familiar to those developers. The command line interface is consistent and minimal. It has the least amount of options possible while still being usable. We strive for same defaults that fit our workflow instead of offering configurability for every possible use case. And Game of Trees is compatible with bare Git repositories, and thus integrates with any tool built around the same format. GOT is not a Git porcelain. GOT is a new system which relies on prior art and takes what makes Git's design great, leaves out the part that makes Git hard to use, and invents new parts for the end result, which serves the needs of the OpenBSD project. So no, Game of Trees does not aim to replace Git. Game of Trees can be used instead of Git for some tasks or in addition to Git. If you are already using Git and are happy with it, then you don't need GOT. Anyone attempting to push an agenda of replacing Git with GOT, where Git is already established, would be highly delusional.
Okay.
Yes, I think the idea of GOT is to provide something a little closer to the CVS that they're used to, but with some of the power of Git. But in particular, GOT does not contain any GPL licensed code. They say, we respect the copyright and license decisions of Git's authors, just as we expect them to respect ours. Most of GOT's code is written from scratch and carries the copyright of its authors and is released under an ISC license. Some parts of GOT are lifted from existing code in the OpenBSD-based system. They ask, will GOT replace the use of CVS in OpenBSD? They say there's no way to know. It depends on how well GOT will develop and how well it's received by the larger OpenBSD project.
Okay, we'll follow this and see where this is going. Interesting idea. Okay, it's time for feedback and questions this week. We have 3 questions from the many we received, but we mentioned that we are doing double episodes, so having a bit more feedback and questions available in our pockets is good to have. So if you have any questions about the BSDs, about the show, anything that you want to mention or tell us, then give us a nice little email or write us one. Send this to feedback@bsdnow.tv, and then it might end up in a future episode. The first person who is on this week's episode is Boston with another question. He has sent us a couple of them already, but there are more. That's no problem because we have also had multiple people send in questions, so that's perfectly fine. He writes, I have 2 FreeNASes. One serves as a production server, the other one is for backup replication. I have never put any attention to the replication task as it happens in the background. It's reliable and has no human intervention needed. But some time ago, by coincidence, he was looking at both FreeNASes just at the time the replication was running. He noticed that it copied data at maximum 360 megabits per second, and most of the time it was even less. The processes were at about 5 to 10% load at the time, and after the replication finished, he ran iPerf, and it showed about 950 to 980 megabits per second of throughput from one to another FreeNAS. And as he confessed at the beginning, he hasn't done any other research on debugging on that so far. And if we please can tell him where to look for that, what tests to run, how to find out why the replication is so slow. He has some hardware info as well. They both have gigabit NICs. Disks are in a RAID Z mirror, no ZIL, no slog, and L2 ARC.
The first benchmark I would do is on the sending system is to run a send. So ZFS send -v, and then whatever options you need to send an incremental or whatever, and then just pipe that to dev null and see how fast the sending system can just read the disk off, or the data off the disks, and then throw it away. And if that's not at least over 100 megabytes a second, then there's your bottleneck. It might be the disks. You will find also that cache has a big bit to do with this. If you do it once and see how long it takes, and then do it a second time, it'll probably be a lot faster the second time, and that will maybe confuse you. It can also depend how much you're sending. If you're only sending, the changes for the last hour from one machine to the other, then it can be that there's just not that much data. But if you're sending recently written data, it will likely still be in the cache, and so should be fast. Also, the replication uses SSH, so that can end up being a bottleneck. Depends how far away the machines are from each other, like what the ping is between them, and so on. So yeah, it's a slightly complicated question, actually. But other one to do is while it's trying to do the replication, if you run gstat, which is geomstat, it will tell you how busy each disk is, and you can see how many IOPS it's doing and so on. And if all your disks are red in the busy column, then your disks are the bottleneck. Because you say RAID Z mirror, that's slightly confusing, because either you're using RAID Z or you're using mirrors. But the number of VDEV you have, like the number of RAID Zs or the number of mirrors, not the disks in them, is the thing that can impact how many IOPS you will have. Since each VDEV is basically provides the IOPS of the slowest device in the VDEV. So if you have a RAID Z of 6 disks, you will get the IOPS of 1 disk, and it'll, be the slowest of the 6.
Right.
Whereas if you have 3 RAID Z VDEVs of 6 disks each, then you will get the IOPS of 3 disks, and so on. So let us know what you find out. But yes, try sending to dev null to see how fast that goes, and also looking at gstat while it's running. sometimes it's also just that if you have a lot of data sets, it's actually does a send and then it's finished. And like it sends each snapshot separately. So it might be that because there's only a few megabytes of data in each one, that you get up to 300 megabits and then that one's done and it has to do some work and they come with the next one and then send it. And it might be deceiving the speed there.
Yeah, that should give at least a bit more information how much performance you can expect and maybe follow up or has found the issue already. Okay, thanks for that question. Next up is Tom with a question about PF. More likely PF on FreeBSD. Hey Alan and Benedict, Tom writes, I installed FreeBSD on my home laptop and installed the PF firewall to protect it. I also bought the book of PF from Peter Hanstein, which is mainly written for OpenBSD, but I thought since PF has been ported from OpenBSD to FreeBSD, it doesn't really matter. Apparently, though, the PF version on FreeBSD is a lot older than the one on OpenBSD, and it does still use the old syntax for the firewall rules. I know I really should email the port maintainer or owner about this, but perhaps you guys have some insights to share as well. Is there a good reason for not porting the latest version of PF to FreeBSD? Oh, yes, I can hear someone already crunch at this question, but because he gets it a lot. Is it because of a lack of time or interest, or is there just no need for porting the latest and greatest version as there are no real performance or feature benefits?
So part of it is that after PF was ported from OpenBSD to FreeBSD, it diverged. A lot of extra code was added to PF on FreeBSD to support vimage, which means that you can have a separate version of PF running in each jail, which allows you to do multi-tenant firewalls and so on. There's a great article over at bsdrp.net, the BSD router project, on how to use one machine to actually run like 20 different firewalls, one for each different department in a company or something like that. That's not really a feature that PF on OpenBSD has. And so there was also a lot of performance work done to make the PF on FreeBSD faster and use more processors and so on. In the meantime, eventually OpenBSD made changes on their side that changed the syntax. And then they've also got some changes to support using more than one CPU a bit better. But the problem at the moment is that the code on either side doesn't really line up. So it's not a matter of just pulling in the new changes from OpenBSD and integrating them with the changes from FreeBSD. And if you reported OpenBSD's PF to FreeBSD, you would lose all the features that were added in FreeBSD. So part of it is a lack of time or necessity. I wouldn't say interest, but necessity. And part of it is just that the PF in FreeBSD is a lot different now.
Yeah, it's probably fair to say that it's diverged too much, that it's more difficult to integrate them, or you cannot just upgrade to the latest version from OpenBSD because there's a lot of code to change.
Yes, likely what you would end up with is the FreeBSD version of PF being called FPF or something, and then reporting the OpenBSD one, and it wouldn't have all the features or whatever. But FreeBSD doesn't want any more firewalls. 3 is already insane. And having the OpenBSD PF, but have it not work with vimage and so on would make it a very weird thing to have in FreeBSD, since the whole network stack supports this virtualization stuff. But yeah, so in the end, it's probably just that no one has had the time to do it, or, more importantly, no one's offered enough money for somebody to find the time.
But help is appreciated, and if people want to see certain things, they can also try to give someone or the maintainer a bit of money to make certain features happen.
Yes. I think the main things are there's not much feature benefit. The new syntax is maybe slightly nicer, but it doesn't really change the functionality that much. And then switching to the OpenBSD PF might actually, rather than improving performance, might make a big degradation because it doesn't have the same, just because the way the whole operating system works is so different between OpenBSD and FreeBSD.
Yeah, so the syntax is different, but it filters just as well. All right, hopefully we answered that question. And the last one is Johnny K with a bit of a follow-up from a previous question we had on an earlier show about changing VTs without the keys. So the virtual terminals in your system can be changed, apparently by typing a couple of commands, or just one. Johnny K writes, "Hi guys, love the show." Thank you. I just started to write in to try and answer Mark's question from a previous episode. According to a FreeBSD forums post, you can use vidcontrol -lowercase s and then 2 and then redirect from dev TTY version 0.
Yep. You don't actually need the redirect. So yeah, just vidcontrol -s and then the number of the terminal you want to switch to, and it will switch.
You could probably put this command in a simple shell script and pass it to the VT to switch to. I'm not at the BSD box right now, so I can try it out. But anyway, love the show and keep up the good work.
Yeah, so you don't need the redirect that the forum post has there. But yes, so it turns out the answer is just vidcontrol -s. Johnny didn't stop there. He said, now that I have made it home to my beloved FreeBSD box, I was able to knock together a short C program to let you switch VTs. And so he wrote a program called CHVT. And if you just call CHVT2, it will switch to console number 2.
The code is in the show notes, of course, if you want to compile that yourself. As we heard from the earlier segments, recording code on a tape is not too well received. On the other hand, if you have to retype it again, so we skipped that, but you can just copy and paste it from our show notes and then run make. Very nice. Thank you for that. And that will hopefully answer the earlier question about how to switch VTIs without using your button switch keys that you're normally using. And that pretty much wraps up this episode. Thank you for listening, as always. Keep the feedback coming. Again, it's feedback@bsdnow.tv, and stay tuned for a future episode.
Yes, and if you went to vBSDcon, write us a trip report. It doesn't have to be very long.
Oh yeah, we always like those.
Tell people what you got out of it so that we can convince more people to come to these conferences.